There's nothing wrong with calculating a deviation to show how far below the mean or above the mean a certain data value is. However, if you've recorded the data values of two people and you want to be able to decide which person has the more extreme data value, the deviations of the two people will only be useful if the two people came from the same population. I'll spend some time explaining what I mean by that. Let's imagine that you're in a situation in which you want to compare the data values of two people to decide which person has the more extreme data value. If the two people came from the same population, then the deviations of the two people will tell you which person is more extreme. When two people are members of the same population, the person with the larger data value is more extreme, and the person with a smaller deviation is less extreme. That's because the person with the larger deviation is further from the mean of the population, and the person with a smaller deviation is closer to the mean of the population. Here's an example. If the mean exam score of a class is 75, a student in the class with an exam score of 80 has a deviation of plus 5, because that student is 5 above the mean, and a student in the class with an exam score of 85 has a deviation of plus 10, because that student is 10 above the mean. The student with the exam score of 85 and the deviation of plus 10 is more extreme because that student's exam score is further away from the mean of the class. So we can see that comparing two people's data values is pretty simple when the two people come from the same population. However, when two people come from different populations, things aren't so simple. When two people are members of different populations, the deviations of the two people won't tell you which person is more extreme. I think that point will make more sense if I share an example. Let's pretend that two different classes have both taken the same exam, and both classes have a mean exam score of 75. In the first class, almost all of the students have exam scores in the 70s. In other words, in the first class, almost all of the students are pretty close to the mean of the class. Overall, the first class has low dispersion. In the second class, the students' exam scores are spread out across a wider range. There's higher dispersion in the second class. In the second class, there are several students in the 50s, 60s, 70s, 80s, and 90s. If you think about it, a student in the first class who has an exam score of 80 is actually pretty extreme. In the first class, almost everyone is in the 70s, so a student with an exam score of 80 is at the top of the class. It's true that that student is only 5 above the mean, with a deviation of plus 5, but that student's exam score is actually pretty extreme, because he or she is further away from the mean than most of the other students in the class. Also, if you think about it, a student in the second class who has an exam score of 85 isn't very extreme, because there are quite a few students who are even further above the mean than that student. It's true that that student is 10 above the mean, with a deviation of plus 10, but that student's exam score isn't very extreme, simply because there are quite a few students in that class who have exam scores that are even further away from the mean. Let's now think about which student is more extreme. The first student, who had an exam score of 80, is actually more extreme, because that student was closer to the top of his or her class. Basically, when two people come from different populations, the person who is more extreme isn't necessarily the person who is further away from average. The more extreme person is the person who has fewer people beyond them in the population. That's why the deviations of two people don't tell you which person is more extreme when the two people come from different populations. If two people come from different populations and one person has a larger deviation and the other person has a smaller deviation, all it means is that one person is closer to the mean of his or her population and the other person is further away from the mean of his or her population. It doesn't necessarily mean that the person who is further away from the mean is more extreme. After all, the two populations could have different amounts of dispersion. It turns out that there's a value that can be used to decide which of two people is more extreme when the two people come from different populations. That value is called a z-score. Unlike a deviation, a z-score doesn't simply show how far a data value is from the mean. Instead, a z-score shows the number of standard deviations that a certain data value falls below or above the mean. If one person has a larger z-score and another person has a smaller z-score, then we'll know that the person with a larger z-score is more extreme, even if the two people came from different populations. For example, if we calculated the z-score of the student from the first class who had an exam score of 80, and we calculated the z-score of the student from the second class who had an exam score of 85, the student with the exam score of 80 would actually have a larger z-score because in the population that student came from, that student was actually pretty extreme. That student was at the top of his or her class.